This is another example where we will need to factor before we can graph. So just remember all of your factoring tricks. I'm not loving the negative out in front, so I'm actually going to start by factoring that out completely. So remember, that's just dividing everything by -1, so all of those signs need to switch. And then when I go to split it up more, I have an x to the fourth, which I can make an x squared and an x squared out of. And since that leading coefficient is 1, this is an example where I'm looking for factors of positive 27 that add up to -12. Remember, that trick only works if your leading coefficient is 1, but whenever I have that, I love it because it does make it easier. So I'm thinking -9 and -3 will work. For that x squared minus 9, that's a difference of squares, so I can keep going with that one. And anytime you can factor more, you should. With the x squared minus 3, to factor that more, you would have to allow factoring with radicals, and that's not usually what we do. We usually only factor with integers. In fact, maybe sometimes we get really fancy and we try and throw a fraction in the mix, but that doesn't mean it's not legal. It just means it's messy and we don't often need to do it. So what I would say is it's fine to just leave it as an x squared minus 3, but remember what the factors give us are the zeros. So if we're imagining setting this thing equal to 0 to get x-intercepts, I'm seeing that x equals -3 would make the first factor 0. X equals positive 3 would make the second factor 0. But this one's a little trickier. It's x squared minus 3 equals 0, or x squared equals 3. And what's extremely important is that you recognize that there are two answers to that. That's x equals plus or minus √3. So if you want to get fancy, you could actually go back up here and say, well, every x-intercept is tied to a factor, so I would have to have an x plus the square root of 3 and an x minus the square root of 3 as factors. It is totally fine if you don't want to go there, but you will have to think about this a little bit. So not only do you have to get down to the plus and minus √3 as x-intercepts, you also will have to think about the multiplicity thing. What would the power on those factors be if we did, in fact, split it up? So if you're going to stop right here, you will have to recognize that that would lead to two x-intercepts, and they would both be multiplicity 1. It's not that you would have a repeated root anywhere. And we'll get into that more, but just to mention it. So my zeros are 3, -3, √3, and -√3. My degree, I could have talked about that first. That's actually really nicely found right from the original before I multiplied it out. So that's the one thing that I really do like when I don't get something that's already factored, is I can see the degree really easily. The biggest power on x is 4, and I can also see the global behavior is going to be a y equals -x to the 4. So it's really easy to see that coefficient as well. So I'm imagining that as x goes to, here, let's draw a little sketch. So upside down x to the 4th looks like this. So as x gets really, really big, we're headed to the right side. Y goes to -infinity. And as x gets really, really big negative, we're headed to the left side of the graph. Y is headed down to -infinity. Okay, so when we go to sketch this, we're going to need our intercepts at 3 and -3. And then square root of 3, I want you to write that exactly as is, but for your own purposes of figuring out where to put that intercept on your graph, plug that into your calculator. That should be roughly 1.7. So we're going to have at plus or minus 1.7-ish, that just tells me where to put those dots. We're going to have x-intercepts. And then I know based on my global behavior that I should start from -infinity. The first piece of local behavior is an x-intercept, and since there's no power on that factor, I'll just cross straight through. What that means really is that if you plug in a number just smaller than -3, you get a negative answer. Just bigger than -3, you get a positive answer. There's no power to make that do anything weird. If the factor is squared, it actually won't change signs there. So we head up a little bit, and then we have to head down and cross at our -√3. This is getting a little bit of a weird slant to it. And then we're going to head down for a little while. We're going to have to come back and cross at positive root 3, and then at 3. And there's the rough shape of our polynomial. So again, our goal isn't to get a perfect graph, it's to get a rough sketch. I've not labeled the y-axis at all. That's fine for these in general. If we want to get more detail, we will, but for now, we're just working on rough shape. I will say that the form that we were given, it's like the standard form of a parabola. You can get the y-intercept really easily. We know it goes through 0, -27. And the reason that's so easy is that to find a y-intercept, you let x equal 0, and x equals 0 will wipe out those first two terms and just leave the -27. I'm not really worried about if I drew my graph perfectly to hit at -27, but the fact that it's negative is a good kind of double check for yourself just to see that it looks like I got my graph right and not upside down. The most common mistake I see on these is people getting their graph upside down.